So in problem number 112, we see that a student has 500 vocabulary words to learn. If the student learns 15 words after 5 minutes, it can be determined that this function approximates the number of words that the student will learn after t minutes. So if well, again, I'll point out why this is an interesting problem here in a minute, but let's go ahead and type in the function into the calculator. 500 times 1 minus e, notice e happens a lot here, negative 0.0061. Again, we use the variable x on the calculator to represent whatever variable we have in our independent variable in our problem here. So you say the independent variable is t. The L, the number of words, let's see, number of words the student learns after t minutes. So L, number of words that the student learns after t minutes, is the dependent variable depending on how many minutes the student has been studying. So we have our equation typed in. We want to first find out how many words will the student learn after 30 minutes. So we're going to type in a 30, y1 of 30. And we see that the student learns about, let's round to the nearest number of words. That would be 84. So about 84 words. Let me get my blue. About 84 words. Now, why this is interesting and why I think you should be interested in it is this doesn't say, this is not a linear function. In other words, if the student learned words at a linear rate, that means if the student learned 15 words after 5 minutes, if linear, then y would equal 15x or 15t. So in other words, 15 words after 5 minutes. So 15 words after 5 minutes would be 3 words per minute, not 15x, but 3x. And so then if you wanted to know, well, how many words would he learn after 30 minutes? Well, learn 90 words after 30 minutes. But this is not linear. And understanding exponential functions, when you see this function, after studying this, you should realize that this is an exponential function. The rate of change is not going to be linear. So if it's linear, then it's going to be that equation, but it's not that equation. It's this equation. We can see that as time goes on, he's not learning words at the same rate as he was initially. He learned 15 words after 5 minutes, but now after 30 minutes, if you think about it, if it's 15 words in 5 minutes, if this is linear, then if you increase this to 30 minutes, then you would think that you'd increase this, you multiply by 6, then you would multiply this by 6, and you'd get 90. Like I said, 90 words. But it's not 90 words because it's not linear. So that's the point. So please keep that in mind when you're looking at this. Try to understand what's happening concept-wise, that we're not learning words at the same rate. But anyway, answering the question, we have second entry, so we can go ahead and edit that entry there. So we have instead of L of 30, we have L of 60, and then we hit enter. And again, if it took 30 minutes to learn 84 words, one might think, well, if it's 60 minutes, it would be 168 words. But it's not. It's 153 words. So again, some more proof that the person who is learning the words at this rate, the more time goes by, the less words they're learning per minute. So they're learning less per minute as time goes by. So that's the whole point of doing that problem. It's a pretty easy problem. Once you know how to plug the function into the calculator and where to put the numbers, it's really, really simple. I mean, the calculator does all the work for you. But it's understanding what's going on here which really makes the difference. So hopefully you were patient with me there and listened to that, and that's making you think a little bit more. Okay? So that's the whole idea. We want to be thinking about what we're doing and understanding why we're doing the things and why the answers are looking the way they are, instead of just kind of doing the problems without even thinking about it. Okay, that's it.